don't believe it when people say, oh, performance testing, wait until the functional testing is done and system test, then you can start performance testing. That is going to be too late. Performance, load, and reliability problems are often design problems ultimately, and if you've got a design problem, you don't want to wait until months potentially later to fish the thing out of there. It's you want that design problem identified and removed fairly early. So don't just say, oh yeah, stabilize the functionality here and then everything will be fine and we'll run the performance test. That's a classic example of the testing worst practice of testing on the assumption that everything is going to pass. And you want to test on the assumption that you're going to find bugs. And in the case of performance, load, and reliability bugs, those are going to be serious bugs. So we should try to look for them early. So design reviews, modeling, as I mentioned before, unit testing, looking for bottlenecks in the units, component integration testing, making sure that subsystems don't create bottlenecks between them and their interfaces. Because once you get into a situation where you've got a really slow, brittle, unreliable system and it's in system test, if you're thinking that you're going to be able to patch that by throwing hardware at it and so forth, that's really not something that's going to necessarily work. And I'll show you an example of that not working here. So on the interactive voice response server project that I mentioned where the IVR server eventually proved to not be a very scalable beast, there was actually a senior technical staff member who had built a spreadsheet model that predicted a lot of the problems that later showed up. It was amazing how prescient that model was, and if you think, oh well, those models can't be really accurate, I mean, he actually predicted the number of simultaneous users that would bring the system to its knees to within something like plus or minus 10%, and so that was pretty amazing. The problem was that this guy had built this thing, but there was no follow-up. Nobody actually took that and said, hey, this is a warning shot. This is the canary in the coal mine, as the saying goes, and we really need to deal with it. And it didn't happen. And so once we got into system tests and later component integration tests and system tests and started finding the problems that I mentioned, like the system crapping out and dying after just beyond 50% load, what happened was there was an attempt to try to throw hardware at it. And so if you think, I mentioned that phrase hockey stick before, and I'll show you what that means. If you graph response time against level of load, and what you'll typically see in a system that's functioning well is a nice kind of gradual, more or less linear increase in the response time as the load goes up. But once you get out to the limits of supported load, which is shown by the vertical bar here, then you're still within the allowed response time, which is the horizontal bar over here. But when you get into a problem, what you see is a couple things. One is you might see the slope of the line clearly indicates that you're going to go shooting out of the allowed response time well before you hit the load. But then you get to the other thing. You get to this hockey stick or nonlinearity. Basically, what's happening here is some form of saturation. Some resource is saturating, and that's a bottleneck. And then, yeah, you can address that. So this first resource saturation that happened on this project was a CPU. So bang in on our CPU board, and away we go. Yeah, okay. And then so here we are with the additional CPU board, and that's fine. That let's see if I can do this properly here. That's maybe on track to actually be somewhere within the range. Probably more like here, a little bit outside, but then wicked nonlinearity kicks in again, and whoosh, there's the hockey stick thing happening. We're rocketing up there, And then, so that turns out to be, we got a throughput issue on the I/O channel. Oh yeah, we'll add some more capacity to the I/O channel. Okay, well, all right. Here clearly on track to be okay, except again, boom, what's it this time? Memory. There's going to come a point where you try to peel the onion. If you start off so far away from where you need to be, as you saw we were over here, that you're just not going to be able to patch this into shape. I mean, it's like you have a car and you're thinking that if I bolt a jet engine and wings and a rudder onto this thing, I'm going to turn it into an airplane. No, it's just it's not. And in this case, it was not only was it like bolting wings onto a car, it was actually more like trying to build a fighter jet by bolting wings and jets onto a metal rowboat. I mean, it was clearly not going to happen, and it didn't happen. The problems were never actually resolved in any satisfactory way, these performance problems. Now, to contrast that with the Internet Appliance project that I've mentioned throughout here, we started with a spreadsheet, and again, this is very similar. There was a spreadsheet on the IVR project. It's just that in this case, the spreadsheet was used as a guide to server design, and then that server design was turned into a actual simulation, and we're now executing the simulation, and that simulation is fine-tuned, and so on and so forth. As I said, there's performance testing in the units and the subsystems compared against the simulation. So by the time we got into system test, you saw that we found some issues there, and of course, you should always expect to find issues in our testing, but there weren't a whole lot of big, huge surprises. Because we were iteratively improving the models and the tests and working through, gradually filtering out the bugs rather than counting on some big bug-destroying miracle to occur right at the end of the project. Okay, so where do you stand? I would say, you've heard me talk about this. You can now go back, look at the lessons that I've mentioned, and ask, how are we doing here? In terms of some of those common mistakes that I mentioned, how are you doing there? Are you making some of those mistakes? Are there tips for success that you could apply? You want to look at figuring out how to do this better and better over time, not just hoping for the best. These field failures obviously are the worst case, where you get out into the field and you go, oh yeah, everything's going to be great. We did performance testing, and then boom, and this stuff isn't working at all. It's really slow. That's that's bad. But almost equally as bad as the situation that I described in the IVR project, where it basically, as that onion peeling went on, and we clearly weren't going to be able to fix it, we could tell that the project was in the process of dying right there, and it did. And ultimately, it pretty much failed. And you don't want to be in these situations. It's really unnecessary. It really is. I mean, these are the things I've talked about. They're not cheap, but they're cheaper than the alternatives. So, I really recommend that you try to take a look at your performance load and reliability testing in light of what I've just covered, and see what you can do better. Because most of us really can do better on this. It's a very complicated thing, and there are plenty of opportunities for improvement. So that's the end of the presentation. I'll put the advertisement up here while we go through some questions. I'll take questions from the audience.